Today we are going to discuss about introduction to limits. Introduction to limits. Okay, let's see. Let's take a graph of y is equal to f of x, which is equal to absolute of x. You take this is our x-axis. This is our x-axis, and this is our y-axis. Okay. Now for every x value here, we calculate absolute of x, and then we mark here as a point. Now let's observe what happens to this function when x is approaching 0. Suppose that initially you are here. Suppose you are somewhere here. I'm standing on this function here. We are here, and this is our x coordinate. As I move this x coordinate from here to here in this direction, approaching to 0, what happens to me? I come down. I'm here when x is here. I'm here now. Okay, and when x is still moving down, I reach here, and when x approaches 0, what am I? I am also approaching to 0 as per this graph. Now this 0 can be approached not only from this position, but it can also be approached from this left hand side. Suppose that another person is at another location, say somebody is here, another person is here. Okay, he is at a particular x value here. This is his x value, initial x value, say x2. Now, as we move this x value here, what happens to this person? He moves down. Now he reaches here. Okay, as he moves here further, what happens to him? He reaches here. Okay, as this x approaches 0, our person on the function approaches to the position 0. So that means when the function, when this person is moving from left hand side, the function value is approaching 0. When x is approaching 0, the function value is approaching 0. This is on the right hand side, this is on the right hand side, not on the left hand side. Okay, now let's come to the left hand side. What happens to the function value f of x when x is approaching 0? What happens to function f of x? Now here x is approaching 0 from the negative direction, so we not give a notation like this. What does it mean? This means that initially x is at a negative location. Now x is moving from here to here. Then what happens to the function function f of x? We have seen in this example the function f of x approaches 0. Then we say limit of f of x when x tends to 0 is 0. And in this case, we write limit of f of x when x tends to 0 from the positive direction, from the right hand side, is equal to 0. In this case, f of x was absolute of x. Fine. Now let's take another case. Yeah, this is a function. This is a function which is defined as f of x is equal to absolute x divided by x. Now let's position two people, one person on the right hand side here there is a person, here there is a person, and here there is another person of the function. Okay, here there is another person. Now initially they are at this location, initially his position here, x position. Now let's make this x come down. X is approaching 0 from here. Let's move x, let x goes to 0. X is not becoming 0, but x is moving as close as possible to 0. And when x moves, this person also moves along with x. So now he is here, now he is here, now he reaches here, and finally he approaching which number? He approaching 1. Okay, then we can write function value when x is approaching 0 from the positive, the function value approaches to 1. Fine. Now let's see what happens here. What happens here? Here there's a person, he moves here, he is moving from here, yeah. He moves here as x moves to 0. So as x approaches 0, our person reaches here. What is this value? This value is -4. And what does we can infer from here is that the value of the function f of x, when x is approaching 0 from the negative direction, it becomes -1. Now in this particular example, we can see that the value of function f of x when limit x tends to 0 from the negative direction is not equal to value of the function when x approaches 0 from the positive direction. These two are not equal. But in the previous case, where we have taken function as y is equal to f of x is equal to absolute of x, both the limits were same. That is, limit f of x when x tends to 0 from the negative direction is equal to limit f of x when x approaches 0 from the positive direction. Both were equal in this case, and in the second example, where the function was defined as f of x is equal to absolute of x divided by x, these two quantities are not equal. Okay? Now, let's take another example. This time we will define the function as, we will define the function as y equals 1 by x square. There's a blue colored plot shows this particular function y is equal to 1 by x square. Now let's analyze what happens to the function when x is approaching 0. Okay, so like as we have done in the previous example, here as well we'll position two guys from right side as well as a left side, and we'll ask them to march to 0. Let's see. So I have one guy here, I have one person here initially, and I have another person here, I have another person here. Okay, now initially he is at a particular x location here. Now I am asking to move in this direction to 0, approaching 0. So what happens? He starts moving, he reaches here, as x is again goes down, he climbs up in a very fast way, in a very steepy way. It's very steep here. Oh, and he's moving and he's moving. And as the x is becoming close and close here, he's moving higher and higher. And where does he reach? It depends on this function y is equal to 1 by x squared. If x is very, very small, say x is equal to 0.000000001, then imagine what will be the value of y. Y is going to be a very huge number. Y is going to be a very huge number. If x is very, very, very small, then y is going to be very, very, very big. Or we say that when as x is approaching 0 from the positive direction, then the function is approaching a very big number, and we say it's infinity. Now the question is it a positive number or a negative number? It's positive because it's going in this direction, so it is positive, so we say plus infinity. Okay. Now that's a case with left hand side. Let's see what happens on the right hand side. The right hand side, as x is approaching in this direction to 0, our guy here climbs. He climbs in the exactly similar way, and he climbs and he goes up and up and up, up and up and up. As x is approaching 0 from the negative direction, he is climbing up and up and up. It's going to be a very big number. Is it a positive or negative? He's going to be a very big positive number. So we can say limit x tends to 0 from the negative direction of the function under consideration is equal to a very big number. It's a positive number, positive infinity. Fine. Now let's move to another example. Yeah, this is interesting. This is a function of y is equal to 1 by x. Now what happens to this function when x approaches 0? What happens to the function f of x when x is approaching 0 is a question. Now this time what we have to do, we have to approach 0 from both the direction, and we have to see are they equal. Fine. Let's position one person here. Fine. You ask him to move x in this direction, then this person moves on the curve this way. He goes to the top. He goes all the way to the top. As x is becoming close and close, he goes to very, very big number because the function is 1 by x. When x is very small, y is going to be very big. So we can say limit x approaching 0 from the positive direction, f of x is going to be very big number, is going to be positive infinity. Fine. Let's see what's happening on the left hand side. Initially let us position a person here. We have got a person here, this hanging on to the graph, a function. We ask him to move, x is moving in this direction, closely approaching 0. Then our person is moving like this, he is moving like this. Now he is going in this direction, he's here, he's here, he's here. Now as x is becoming more and more and more and closer, he's going down. He's going to be very, 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 very big number, but in the negative direction. Okay? Then we say limit x approaching 0 from the negative direction, the function f of x becomes a very big negative. You see, this left hand side limit and this right hand side limit, they are different. One is a positive infinity, another one is negative infinity. Okay. Now let's take another example. Okay, fine. This is a plot of y is equal to sine x divided by x. It's a plot of this function. Now what happens to this function when you are approaching 0? Okay, so say initially our person is here. Initially our person is here on the right side, and another person is here on the left side. Another person is here on the left side. Now as this man goes in this direction, as x is becoming close to 0, our person runs along this graph in this direction. He reaches here, he reaches here, he reaches here, then he starts climbing, now he reaches here, he reaches here. As x is approaching 0, he is approaching 1. And what happens to our other person who is on the right side? Initially he is here, x is moving close to 0, then he is moving along the graph like this. Now he has reached here, he has reached here, he has reached here. Now he is going all the way to 1. So we can say on the right side, the function is approaching, when x is approaching 0 from the positive direction, the function is approaching 1. Now when the function is approaching, when x is approaching 0 from negative direction, the function is approaching again 1. In this case, this limit, which is called left side limit or left hand limit, is equal to right side limit or right hand limit. Both are equal in this case. Fine. Now let's define the limit. Now we have seen what is a left hand side limit, and we have seen what is the right hand side limit. Now the limit is said to exist when a limit is said to exist only when a left hand side limit equal to a right hand side limit. Okay, now let's take another example. We have seen many examples of left hand side as well as right hand side. Now let's take another interesting example. This is a plot of y is equal to sine 1 by x. It's very interesting plot. Now what happens to the function limit? What happens to the function when x is approaching 0 from the positive direction is the question. What happens to the limit? What happens to the limit when x is approaching 0 from the negative direction is the question. So first, in order to find this, we have to position one person here, and in order to find this, we have to position another person here. Now we ask them to move as we change the x in this direction, and x is becoming 0 from here. Here also x is becoming 0 from this direction. Both the guy starts running. This person starts running in this direction. He starts moving. He reaches here. He starts moving. He reaches here. He reaches here. Then he reaches here. He goes along like this. He goes. Then again he comes down. Again he goes up. Again he comes down. But what is he ending to? It's not clear. It's not visible. It's oscillating. Okay. Now let's see what happens to the right side. As x is approaching 0, a person starts moving. He starts moving on the curve. He reaches here. He starts moving on the curve. He reaches here. He reaches here. And he again climbs up. And again he climbs down. And again he climbs up. Again he climbs down. Now let's see the same graph, only thing here the values are very small as we are approaching 0. This is 0.01. So this is what's happening. This is the right hand side. You see here the function is approaching. The person is climbing, he's coming down, he's climbing, he's coming down, he's climbing, he's coming down, he's climbing, he's coming down. As x is approaching 0, he's keep on doing this. There's never ending process. So he is not reaching anywhere because this is oscillating. And that's the reason we say that here the limit doesn't exist. Like the right hand side limit, x tends to 0 from the positive direction of f of x do not exist. Now, in the same way, when he moves from the negative direction, when he moves from the negative side, the minus f of x, that's again do not exist. Fine. Now let's say let's take some properties of limits, some important properties of limits as an extension to this graph. Let's study some important properties of limits. Okay, fine. What is shown in this graph is y is equal to y equal to sine x by x. Now what is limit x tends to 0 f of x? We have to find this. So to find this, basically you have to calculate two limits. You have to see what happens when x is approaching from positive direction. You have to calculate this L1. Then we have to calculate another limit. What happens to the function when x is approaching 0 from the negative direction? You have to calculate L2. Now let's see, in this case, as x is approaching 0, the function is approaching to 1. So L1 is 1. Now from here, as the x is moving in this direction, the function is approaching 1. So L2 is also 1. Now since both left hand side limit equal to right hand side limit, we say limit x tends to 0 f of x exists and is equal to 1. Okay, so we can conclude that limit x tends to 0 f of x equal to 1. or limit x tends to 0 sine x by x equal to 1. If this is the case, then what happens to this limit? Limit x tends to 0, 3 plus sine x by x. I'm making a small change in the function by adding a constant 3. Then what happens to this limit? Let's study that. Okay, for that I have plotted the graph of 3 plus sine x by x here. Yeah, this is the graph of 3 plus sine x by x. This is the graph. Now what happens as x is approaching 0, the function approaches 4 from the positive direction, and from here, as from the negative direction, as x approaches 0, the function again approaches 4. Then we can write limit x tends to 0 from the negative direction of f of x equal to 4, which is again equal to limit x tends to 0 from the positive direction of f of x. Since these two are equal to 4, we can write limit x tends to 0 f of x equal to 4. Fine. Now, that means we can write limit x tends to 0, 3 plus sine x by x equal to 4. This is a result which we have obtained by careful observation of this graph. By observing this graph, we have got this result. Fine. Now, just as let's do a small analysis here. You see, we have already seen previously that limit of sine x by x is 1. Limit of sine x by x when x is approaching 0 is 1. This we have already seen. Now you observe this and you open this bracket here and apply the limit to both the quantities, and what happens? From here you open the bracket and you get limit x tends to 0, 3 plus limit x tends to 0 sine x by x, which is equal to what happens? What happens here? 3 is a constant function. When x is changing, approaching 0, 3 remains constant. So limit x tends to 0, 3 is 3. Plus limit x tends to 0, sine x by x, which you already seen, this value is equal to 1. So 3 plus 1 is equal to 4. So using this particular result, without plotting the graph, we are able to find this result. We are able to find this result. Okay. Then we can extend what we have written now. We can extend and write a first property of limit as limit x tends to a, f of x plus g of x can be written as limit x tends to a, f of x plus limit x tends to a, g of x. Okay, in the similar lines we can write one more property. Now this is the property number 1. We can write property number 2 as limit x tends to a, f of x into g of x equal to limit x tends to a, f of x into limit x tends to a g of x. Okay, now let's see, can we compute a limit of okay, let's compute limit 2 into sine x by x when x is approaching 0. Using the previous property, we can write this as limit x tends to 0 2 into limit x tends to 0 sine x by x, which is equal to, as x is approaching 0, what happens with 2? 2 remains as 2 because it's a constant. 2 into what happens to limit x tends to 0 sine x by x. This we have previously seen graphically that this is approaches 1, 2 into 1, and so this is equal to 2. So let's plot a graph and see. Already plotted the graph. You see, as x is approaching 0 from positive, from here and from here, as x is approaching 0, the function is approaching to 2. From here also the function is approaching to 2. Since left hand side limit and right hand side limit both are equal and both are equal to 2, and that's where the limit is said to exist, and the limit value is 2. Okay, that's the end of it. Thank you.